Hello, we are going to go ahead and work on part 2 of the midterm exam review. All right, don't worry that it says 2021, 22. Guess what? It's the same reviews. We don't change it up that much from year to year. Okay, so you're given the information that probability of A is 0.3 and probability of B is 0.4. Do you have enough information to compute the probability of A or B? So I went ahead and I added an extra page. So this is the same review that I was working on before, my notes. And we're going to start on part 2 of the review. And one of the things you need to know is probability of A or B equals probability of A plus probability of B. So you guys are used to doing that part. But you have to subtract out what overlaps. So if you don't know the probability of A and B where they both intersect, so for example, if I was drawing something like a Venn diagram, I know you guys probably aren't that crazy about Venn diagrams, but say that's the area for A, and this is the area for B in a Venn diagram, and then we have this is everything else. So the A and B is this section right here. Actually, let me go ahead and do that in red or something. So this piece right here is that piece right there. So it's all of this. Sorry, I'm doing this with my mouse, so it's not the best. So you need to know, and then the probability of A is actually, let me go pick a different color. So if this is A, it's going to be all this, right? Including the overlap. And if we did B, we'll pick another color. I had dark green on that one. We'll try blue. So if probability is B is blue, it's still kind of hard to tell apart, isn't it? Oops, Control Z. We don't go outside of B, so this would be B right here. So let me go ahead and say this is B. This is A. And then the rest of this is the not AB. Okay, so the problem with trying to get A or B, it's just this area combined. But if you add A and you add B together, you're double counting that red area. So going back to our assignment, no, you need to know the value of probability of A and B. All right, if you know that the events A and B are mutually exclusive, do you have enough information to compute probability of A or B? Well, let's see. That means then you could have, in this particular situation, we could, because if things are mutually exclusive, let me come back here. If mutually exclusive, what does that look like? So mutually exclusive means A and B don't overlap. So what does that look like? So let me draw you a Venn diagram of that. So it's like you have, here, Control Z. I wanted circles. So you have your A and you have your B, but they're not, it doesn't matter if they're the same size or not, by the way. And then you have the rest. There is no overlap. The probability of A and B equals 0. So if I put A in here, there's A, and here's B. In this picture, probability of A or B equals 0 because no overlap when mutually exclusive. All right, so I'm going to draw a little arrow so you know that's what I'm talking about right here. So there's no overlap. Where is it? Okay, so that's some notes that you can make to yourself. So this piece goes together right here. Okay, that piece right there. All right, let's go ahead and go to the next problem. So yes, we know probability of A and B equals 0. So we can just go ahead and figure out, or probability is add, right? Or probability is add. Do you see the difference between those two? So make sure you got that. We'll go ahead and hit submit. And voila, we got both our points. On to problem 2. You're given the information, probability of A is 0.3 and probability of B is 0.4. Whoa, this feels duplicated. Maybe it's just a different variation. All right, do you have enough information to count? Oh, this is a slightly different twist. So usually, if A and B are independent, then probability of A and B equals just the probability of A times the probability of B. But if not, then probability A, it's going to be like a, if not, then it could be something like this. It's conditional probability. It looks offline now. Equals probability of A. It might be this way. Probability of times probability of B given A. All right. So you don't have to do that too much, but the main thing you need to know is if these are independent, you can just multiply the normal probabilities, all right? Multiply normal probabilities. And this bottom one using conditional probability. So conditional are a little bit trickier. All right. So for example, probability of B given A, let me go ahead and write that down so you remember what that means, is probability of B given A. All right. So you know that you're in the, so as an example in the Venn diagram here, here we know that if we know we're in A, then we know the probability of B given A is just going to be this red piece over the whole thing, because that's the fraction of B that overlies, that's the fraction of A that has B in it too. So it's a little trickier. Hopefully, let's go ahead and look at our question, see if we can clarify that for you. So you do not have enough information because we need to know if these are independent, all right? So that would be, you need to know if the events are independent or one of these probabilities, which is what I was just telling you, all right? And then if you know A and B are independent, do you have enough information? Yes, because we just multiply. So what I wrote here, if A and B are independent, then you just multiply them, all right? But if they're not, you need to know these special probabilities, these conditional probabilities. Oh, good. I did pretty well on that, I think. It's almost like I could teach stats or something. All right, hit submit for testing. Okay, 4 down, 23 to go. Question 3. For a class activity, your group has been assigned the task of generating a quiz question that requires use of the formula for conditional probability to compute probability of B given A. Your group comes up with a question. If A and B equals 0 and probability of A is 0.2, what is the probability of B given A? Okay, so what is wrong with this question? So I'm going to kind of, so here's the question. I'm going to copy it down. We're going to look at it. What's wrong with this? All right, so let's go ahead. And what problem was that, by the way? That was, because it doesn't hurt, question 3. Okay, number 3 on the review. And so what's wrong with this question? Oh, it looks like somebody's looking at my Cami right now. I wonder if they see me typing. Yeah, because some people are trying to get ready for their midterm, and I'm recording this a little late. I've been swamped, guys. Sorry about that. So I had to make another midterm, and that was my higher priority. Okay, so we're going to do the formula. So let's write the equation, right? Probability of A. I'm going to write given because when I don't write given, see if I can do a quote. Given, oh, actually, given B. Oh, actually, B given A, because first one, it's always the first one. And I'm just doing these weird quotes just so it doesn't turn wonky on me, all right? So the probability of B given A equals, let's see, why is it having 2 parentheses? There we go. Equals the probability of B and A divided by the probability of A. All right. So if we do this, probability of B and A is 0.40, right? Divided by probability of A is 0.20. We should make this bigger, don't you think? Let's make that bigger. So there's a problem. What do we get? Equals 2. Well, can we have that? Can you have a probability of 2? So this won't work. Let me go ahead and write red. Yeah, scary. This won't work. Probability can only be between 0 and 1. It cannot be 2. That's our problem with this problem. That's our problem with this problem, yes. Voila. Okay, so that's the answer in number 3 on the review. We've got an issue because the probability won't work. So A and B cannot be greater because now we're getting an answer bigger than 1. We'll submit. And on to number 4. Does it pay to ask for a raise? A national survey of heads of household showed the percentage of those who asked for a raise and the percentage who got one. According to the survey of the women interviewed, 26% had asked for a raise. And then they said, oh, what's the probability a woman had asked for a raise? Well, 26%, but you don't see a percent here, so you better put this as a decimal, all right? Then, of those women who asked for a raise, 45%. So they said, if they asked, given they asked for a raise, what's the probability they got it? Oh, that's a 45%, all right? Then finally, they said, hey, what's the probability they asked for the raise and got it? So we're going to go back to that formula. I'm going to rearrange it, okay? Probability of B and A equals probability of B times and it can vary. Probability of B given A, all right? So what that means in this problem, I think this is problem 4. So number 4, let me go ahead and change the color on this. Maybe not. There we go. So on number 4 on the review, for C on the review is like this. Just multiply both probabilities together. All right, so I'm actually going to do Google calculation. So first of all, what are our two numbers? 0.26 and 0.45. Hey, Google, what's 0.26 times 0.45? And 0.117, so I'm going to go ahead and put that in the answer, 0.117. Enter your answers to 3 decimal places. Since these are pretty even, it should work. I'm going to see how WebAssign is behaving on this problem. Let's go check it out. And it was very happy with my answers. Notice, because it was 0.260, and that's why those worked. Okay, so again, on this problem, it'll probably look familiar. It's going to ask you the basic probability, and it starts by talking about that. Then the given probability, and it gives you that. So super easy. Just make sure you put the right number in the right thing. And then you multiply both probabilities together. And how does that work intuitively? Well, 26% of 45% should be asking for a raise and getting one. Well, that's about a quarter of 45%. So, yeah, about 11%, 12%, somewhere around there. So intuitively, that should make sense as well. Okay, drop a thumbtack and observe how it lands. Describe how you could use a relative frequency to estimate the probability the thumbtack will land with its flat side down. Okay, so what could we do? We could count the number of times the tack lands flat and divide by the total number of times drop. So we're doing probability. The thumbtack, well, that sounds right. Let's check the other one. Flat side down, subtract the number of times it lands point down. No, that's too complicated. Count the number of times the tack lands point down. No, we want it flat side down. So this is our correct answer. What is the sample space of outcomes for the thumbtack? Well, it should be, well, so probably down and up. We're going to say down and up. Yeah, I don't see how it's left and right. And how would you make a probability assignment for the sample space? If when you drop 500 tacks, 300 land flat side down, so you could say, oh, this is 300 divided by 500. Sometimes this lets you put in fractions. I'm going to see if it's nice. So that means the other 200 times it does not. So we're going to test and see if you can put in a fraction here. Submit for testing. And yeah, see, it'll do that for you. Isn't that cool? Then it gives you an exact value. This is 0.4, by the way, and that's 0.6. So that's fine. Again, your numbers will change. Minus 300, so you're going to have to figure out what that is. Okay, there are 6 multiple choice questions on an exam, each with 3 possible answers. Determine the number of possible answer sequences for the 6 questions. So basically, the probability here is, let's see, which problem is this? Let me go ahead. This is number 6 on the review. So number 6 on the review, let's go to blue. Oh, we'll keep that one green, and then I'll type. There we go. Now we'll hit blue. Number 6 on review. 6 MC questions with 3 answer choices, right? How many ways? That's what they're asking. Well, how many different ways can you answer the first question? Oh, there are 3 there, right? And the second one, still 3. If you pick B as one of the answers for the first question, that doesn't mean you're not allowed to pick B on the next one. So you could actually pick any of the 3 letters on each of the 6 questions, which means you multiply them all out. So that's 3 to the 6th power, or you could say 3 times 3 times. You could just punch that all in your calculator, and you would get 729. So I'll go ahead and put 729 in. Only one of the sets contain all 6 correct answers. So there are 729 sets. Only one is correct. So if you're guessing what's the probability you get that one, well, it's, again, we're going to use the cheat here. 1 over 729. And WebAssign should be nice and let us have that instead of making us grab a calculator. See how that works? Beautiful. Which of the following is not a continuous variable? So this is kind of an old, well, oh, that's right. We talked about discrete random variables. So that's how that showed up. Well, if you were able to chop up the thing, so what does continuous mean? So we'll go ahead and do this. Continuous means you can pick any value between 2 other possible values. All right. So for example, on this question, so they'd be valid outcomes. These would be valid outcomes. All right. And so you can cut it up very finely and it would be allowed. So time to solve a problem, you could actually divide it down to nanoseconds if you wanted to. So that could be a continuous variable. Temperature is also continuous. It doesn't jump up by a degree. It just goes up little by little by little. Height is also continuous. But if you don't have jumps, just go 1 child, then 2 child. No 1.5 children, that's not a good thing. Not a good thing. And now if we talk about average, that's different. But the actual variable, you either have 1 child or you have 2, or you have 3, or you have 0. But you don't have half a child. That would be bad. So don't do that. Okay, so let's go ahead and submit that. We're doing pretty well. We're halfway through. Okay, the binomial distribution for p equals 0.2 and n equals 100 has a standard deviation of sigma equals 4. Fastest way to figure this out, we go to our favorite toy, the Staplet. They said binomial. Let's click binomial. What did they say? N was, let me go back. N is 100, p is 0.2. So I put 100 0.2. Now you could do the formula. You could do 0.2 times 1 minus 0.2 times 100 and take the square root. Or you could just say, oh, the standard deviation is 4. I told you right there. So we'll calculate it for you. So we're going to say true right there. And let's do the next one. Which is the following as an example of a discrete variable? Oh, that showed up twice. This feels very familiar. I probably could have deleted this one. It's kind of doopy. Yeah, number of brothers and sisters. Now, I'm not going to count. Well, let's say you're like, but wait a second. I could have a half brother. Okay. But normally you don't have a quarter brother. And you don't have a tenth of a brother. That would be very weird. Okay. So there you go. And let's go ahead and submit these two. Yeah, we don't cut people up. People are not continuous variables. Not a good thing. Okay, number 10. And in an ESP experiment, subjects must predict whether a number randomly generated by a computer will be odd or even. What is the probability that a subject would guess exactly 18 correct in a series of 36 trials? Back to the staplet. So we got n is 36, x is 18. Now, the problem is when I set this puppy up, what do we say? What was x? So x was 18, n is 36. So I know n is 36. But they're flipping a coin. So what's the probability I get the coin flip right? You hopefully remember that's 0.5, right? And they said, what's the probability of getting exactly 18? So I go here, put exactly 18. 13.21%. Now that's saying percent. Now if your staplet is giving you percent and most of the answers are in decimal, not percent, you might want to go back to your staplet and click down here on adjust color and say, give me decimals or give me death. Or cake. Cake would be better. I like to have a lot of decimal places. Usually it's fine. And then I'll hit go now and you can see 0.1321. I can say, there we go. That's my answer, 0.1321. So on binomial distributions, the main thing to remember, what do we write about binomial distributions? Well, let's see. Let's go ahead and say for binomial distributions, I'll make this in blue. N is the number of attempts. P is the proportion or probability on one attempt. Just in general, not to be confused with multiple attempts, all right? And then X is the number of successful attempts. All right, so use staplet, use binomial distributions in staplet. And all the work's done for you, everything. So if we go here, what were they saying? Oh, 0.1321, we'll go to our, here, there you go, 18. What is the probability the subject would guess more than 20? So the main thing here, what is more than 20? Well, make sure you hit more than 20. And kind of look here, right? So you can see it's starting from X. Oh, did it change on me? No. More than 20. Oh, so wow, look at that. That's interesting. Can I actually click on? I'm learning things. Oh, look at that. More than 20. So I want to start there. I learned something new today. Look at that. So from 21 to 36. So cool. So that probability is 0.2025 because that is more than 20. If you want to be sure on your language and that matches the problem exactly, you might say, I'd like this one better because it matches the words. Same answer, so we're good. So very cool. I just learned something new. Okay, if Pn is 80 and Qn is 20, then what is the shape of the binomial distribution? Okay, this needs to go in your note sheet. I'm going to put this in red. All right, red. Write this in your note sheet. All right. For the distribution, for the binomial distribution to be symmetric, NP and both NP, N times P, and N times Q It must be at least 10 or higher. Note Q equals just 1 minus P. So Q is the probability of failure. All right. So going to that, let's go back to our question. Let's see. Both of these are bigger than 10. So we can say it's approximately normal. In fact, let me add, to be roughly symmetric, i.e. approximately normal. All right, both, and so there we go. I'm going to put that. There you go. Okay. So it says normal. It really should say approximately. I will not give it a hard time. So that's 10 and 11. Let's submit those. Almost done. Not as long as the last review. Sorry about that. Okay. And I guess I could have clicked on the question number. A stationery store has decided to accept a large shipment of ballpoint pens if an inspection of 17, that looks like an N, randomly selected pens yields no more than 2 defective pens. So I'm going to binomial and I'm like, this feels like my N is 17, but I'm not sure what probability is yet. So let's go back to the question. 5% is defective, so I'm going to put 5% in there. Now, by the way, remember 5% is 0.05, not 0.5. Make sure you put in the right number. So there we go. And when are they going to, so if no more than 2 defective pens. So they're okay with 0 defective pens, they're okay with 1 defective pen, and they're okay with 2 defective pens. So I'm going to go back to my stafflet and say, pretty much from here on down, right? Or you could say at most 2 defective pens. So you can see it's 0.9497. I'm going to do it this way. Same number. So there you go. At most. So that's a probability it's accepted. Make sure they can change the wording on here. See, yes, look. What's a probability it is not accepted if 15% of the total shipment is defective? So we're going to go back to our stafflet. We got to change the P. All right. And then we got to do not accepted. That means there are more than 2 pens that have bad areas. So all this right here from 3, 4, 5, all of that. Now I could say at least, or I could just say more than 2. So it was 0.4802 here. Still 0.4802. So I'll take that, put that in my blank, and hit submit. And voila, both were correct. So again, pay careful attention. If it says not accepted, that means you actually want more than 2 defective pens because you want it to be rejected. If you want it accepted, less than 2 or less defective pens, at most 2 defective pens, that sort of thing. All right. Okay, according to Harper's Index, 50% of all federal inmates are serving time for drug dealing. Well, that's interesting, like a flip of a coin. A random sample of 15 federal inmates is selected. Feels very binomial, so I'm going to go and use 50% and 15. So let's set that up. 15 and 0.5. Should have an average of 7.5. That makes sense. Let's go back to our question. What do they want? What is the probability that 13 or more are serving time for drug dealing? So back to our binomial, 13 or more. So I could go over here and just highlight, voila. Or see how it shows 13 to 15, or at least 13. Pretend that's 13. And you see 13 or more. Yeah, we're getting the same answer. So that's good. It's kind of nice to verify it that way. So let me go ahead and put that in our website. What is the probability 6 or fewer? So go back, 6 or fewer. Now, by the way, when you're doing these, so that would be at most 6. When you're doing these, you probably don't want to do what I'm doing right now, which is like putting all my answers in at once. Because I kind of know what N and P are. I'm very comfortable. I'm not too worried. So when you're doing a quiz like this, what you might do is put this one in, the A one in first. Say, let me just make sure I'm on the right track. Hit submit for testing. And then you can say, oh, good, I did get that problem right. I am doing this the correct way. And then you can paste. And then there you go. You can just submit these one at a time just as you go along so you can make sure you're getting them right, okay? What's the expected number? That is the mean, also known as the expected value, the average, all of that. It's the same thing. Remember how we said it was going to be 7.5? 50% out of 15, that would be 7.5, so 7.5. All right, and then we'll put that in. And then last but not least, sorry, this one's kind of a meanie, so you can see all those are right. All right, there they are. Beautiful. So the Orchard Cafe has found about 10% of diners who make reservations don't show up. If 70 reservations have been made, how many diners can be expected to show up? So that's not the 10%. This is a very mean question. Don't blame me. The book made it. Anytime you see this, the book made the question, not me. All right. So anyways, so you can easily fix this by changing this to the percent of people who do show up. So here I'm going to put 70 for my N, but I'm going to do 0.90 for my P. So we said 70 and 0.9. All right. And then there we go. Now, here's the funny thing. I'll show you in just a second. So I have 63 as the mean and 2.51 is the standard deviation. 63 and 2.51. All right. Now, here's the interesting thing. What if I had done the 10%? And some of you, I know you've been working on this review. I'm like, wait, Mrs. Overman, I put in 0.1 and it gave me the 2.51. Well, that has to do with the formula for standard deviation. Let me show it to you real quick. You don't have to memorize it. But sigma, which is standard deviation, by the way, I could write SD. Okay, I'll close that. Equals the square root of, where's my square root? There you are. Of N times P, whoops, let me get in there. N times P times Q. So what happens if you switch Q and P, they're just the opposite of each other. Let me make this bigger. This is so pitifully tiny. P and Q are the opposite of each other. So if I switch one, it just switches the other and you still get the same answer. So if you go binomial distributions and you put this in and you're going, Mrs. Overman, my standard deviation is correct. Yes, it works for either 0.1 or 0.9 because those are complements. It's still 251. But the means change a lot. The means over here for 0.9, for 0.1, it's way down at 7, right? It's way down here. So in this question, we're saying show up. What is the expected number to show up? So we need to make sure we put that 0.9 because 90% of our people show up. So 2.51, 63, submit for testing. And we're all done. We got all our credit. And hopefully you are ready for your midterm. And I hope you have a fantastic holiday break.